record, zoom in a little bit. All right, so there's our 5-number summary. Now, how many states between 10 and 5? Just number 5, yes? What's the distance between 15 and 10? How about 19 and 15? How about 36 and 19? You see, those distances are not uniform, are they? No. They're not uniform. If they're not uniform, that means this data set has some interesting deviations in it, right? Now, we shouldn't measure it with the standard deviation because we already talked about the average being too skewed probably with the way the data is lined up. But that doesn't mean you can't talk about variation within the data itself. So what I want to do is, I want to go back to the raw data that I have on the Excel image up here. Let's turn this bad boy back on. There you are. And I want to find these values on the Excel image and see if you can understand why they are what they are. So, can I erase the stuff that's on this board right here? Is that okay? You guys got it, right? All right. So I actually want to draw on the, I want to draw on the image. I wish we just covered all the walls in the room with whiteboard. Yeah. And just not have paint. Or not get pissed at me when I do draw on the walls. Which they sometimes do. There we go. Oh, we got another one? No, I thought I missed it. There was one over there. Doors and white. I know, and I bring markers that, oh goodness. And I bring markers that I can write on the doors, but that thing's so small and faced the wrong way that you guys can't use it. Yes, that's what I would love. Like, why do we have this gap in the middle here? Yeah, I don't get that.
It's frustrating.
It's frustrating. Frustrating.
It was cheaper to buy 2 small ones than it was to get 1 big one.
Costco has proven that it's wrong. The whole reason Costco exists disproves that theory. I mean, you would not have that store, right? Okay, so the minimum value, yes, is 5, and there he is. Your maximum was 36, and there he is. Your median was 15. Which one of those is it? Well, let's do it old school. How many data points were there? Good. Let your eyes go on back over there. Look at the very top. N equals 31. That means your 16th data point, right in the middle. Count with me. 16. It's that one or that one, depending on. It's one of those 3. So there's your middle. So right here, the bottom 15 are here. The top 15 are there. Fair enough so far? Goodness, good, okay. Now what's the median, what's Q1 of 10? Where do you think that's going to be? So here's your median right here. We'll just call this guy the median.
At the 8th data point?
It has to be, doesn't it? Because you've got 15 in that bottom half. Halfway up 15 is going to be the 8th data point. 7, then the middle, then 7 more. So, 1, 2, 3, 4, 5, 6, 7, 8. It's one of those guys right there. There's your Q1 of 10. Fair enough? Where's Q3 going to be? Okay. I want to use the 8 again because I can't do the math in my head right now. But the back 15, starting here and ending there, go up 8 from that one, right? 1, 2, 3, 4, 5, 6, 7, 8. There's your 19. One of those 19s. Boom, you're 19.
So we counted 2 on top of the median.
It doesn't matter which one. Oh, you have to. Yeah, because it's literally counting. When it puts them in geographical order, like Tasha said, it's going to stop at one data point, and then it's going to basically like a pair of scissors and go. So even though those two 15s are equal to the median, the geographicness makes them all laid down into a flat line. And that's just a consequence of the formula. That's how we discuss it. It gets interesting, as Nathan pointed out, when you get a bunch of repetition. But what happens in general, as the data sets get larger, the repetitions, those random fluctuations begin. Like we don't get this. This is very interesting here, yes? Very, very interesting. We got 5 13s. That's not going to happen when you start having hundreds and hundreds. I'll show you the actual collated data set here in a minute. I've got data from the past couple terms all together. Now, this is fine and dandy, but the problem is that gets hard to look at after a while. I mean, circling data points is kind of a pain in the butt. So what people have come up with is, I put it in the right place, I think I am. There's a graphic that goes very, very nicely with dot plots, but it also goes very, very nicely on its own, called a box plot or a box and whisker. So a box plot or a box and whisker diagram. I don't know which one your book uses. And what it is it's a graphical visual of what we just kind of circled, but it's not so random, like draw an arrow, draw a circle, draw an arrow. In other words, it can exist without the dot plot. So here's what you do. You identify your 5-number summary, which is now turned off. You identify your 5-number summary first. You crunch the numbers and get those 5 numbers. More practice on that after the break. Then you put 2 small vertical lines above the min and the max. So this guy right here, you need to have a horizontal scale. So if you guys are trying to draw this in your notes, I would just draw a horizontal scale. You don't have to go up to 50 if you don't want to. You can just maybe draw a horizontal line and go like 0, 5, 10, 15, 20, and so forth. That's probably going to be enough precision that we collect on this data. So you draw one at 5, you draw one at 36. What did you just demarcate with those two vertical lines? The max and the min, exactly. The whole rate, all your data lives between these 2 values. So now you know the universe of your data set, your sample, or your population, whatever, usually your sample. Now, to get a little more specificity, draw 2 more vertical lines that are a little bit bigger over Q1 and Q3. So Q1 was 10, Q3 was 19. And make a box out of those guys. There's your box. There's your box. Do 1 more of those bad boys on the median. Median's going to be at 15. Yeah. Right there. Where are the whiskers? Exactly. The whiskers connect the box to the ends here. And I've been trying for years to figure out, why it's called a box and whisker, and I finally figured it out when my cat woke me up one morning, on my chest, purring, looking at me. Looks kind of like a cat's mouth, with 2 whiskers, one on either side. They look like a cat's nose. If you really try to think that that's what it is. Imagine a cat with 2 whiskers and a square face. Like a Picasso cat. So, there's your box and whisker diagram. Now, I love it. I personally love these things. I want to do this real quick. I want to sketch a horizontal just like you guys did. And I'm going to put a few values here, just like, I'm guessing just like you guys did. Okay, so that's decent. I love it when it's with a dot plot like that. Because the dot plot gives you what? Say it again, nice and loud. Emily, nice raw data. You get the raw data. Is that an ideal world? Of course. You'll hardly ever get raw data. I could just sit here and ask you guys questions and collect data like I just did, which is gay. But what's awesome about the box plot with the dot plot is you see the actual clustering of the data. You see why this whisker is longer than this whisker. Let's go back to what Carolyn said, right? Why is this whisker longer than this whisker? Why is the right whisker longer than the left whisker? Say that again.
The concentration of data is different.
What is the right whisker's data compared to the left whisker's data? More spread out. So what we've just done is we've talked about concentrations and standard deviations without using a calculation of standard deviation or concentration. We can just look at it and go, oh dude, the whisker's longer, that means the data's more spread out. You don't have to quantify it necessarily. As a matter of fact, you shouldn't quantify it. Because trying to quantify it ties back into the average, which is skewed. Fair enough? But what's beautiful about this too, even if you don't have the dot plot, can you tell that the top whisker is more varied than the bottom whisker? Even without the raw data, you get that, which is totally bitchin'. So, the question is, why do we bother putting the box up there? Here's another question. Why the box? Why do we bother putting that box around from 10 to 19?
Because that's
Please!
the middle.
Oh, go ahead. I think you're saying the same thing, aren't you guys?
Yeah, I was going to say, because isn't that where most of the data is?
Define most.
50%?
The middle 50%, exactly. So now you've got different 50%, don't you? You've got the median that separates the bottom 50% from the upper 50%. And now you've got the quartiles, which separate the middle 50%. So you've got these two different, yeah, exactly. You've taken out the extreme left and the extreme right and come into the middles. Is one better than the other? What's your gut feeling? Can you make a decision on that right now? And guess what? You never can. Because nothing is better than the other, it just gives you one more point of reference. One more pointer. I like the idea of most. You might decide to trim off those, because if there are extremes, they most likely will be in those two. So if you focus on this, you're looking for like typical data. Middle 50% will be your typical data. There's a corollary that I want to kind of paint here and bring into next week. That's kind of like your, if you will, 2 standard deviations on your bell curve. It's not exactly right, is it? By percentage-wise, it's not right, because within 2 standard deviations of the bell curve, you get 95% of the data. Here, you're only getting 50%, so you'd have to bump out more to pick up more. We'll hold that for the very end of today and or the beginning of Tuesday. Go, Lauren.
So since the one on the right side is a lot longer,
Uh-huh.
the median, how we chop things off.
So you're tying it into that trimmed mean idea?
Yeah.
The question I have is, when are you going to start chopping?
When they're equal on both sides, or
Well, not necessarily, not necessarily. I mean, what do you want to chop? If you're looking at averages and you want to be able to use an average, what do you want to get rid of?
Yeah.
Outliers. Define an outlier for me.
the ones on the
36.
higher and the lower end of the
How high?
It depends on what you're working with.
That's actually the best answer. The question is, there is a way to quantify outliers mathematically. The interesting thing is there's not one way to do it. There's at least, I've seen 6 different ways to do it. I promise not to torture you with that. I'm going to give you 2, and we're going to start learning them today. We'll definitely do them on Tuesday of next week. The idea is, if you have bell-shaped data, it's done one way. If you don't, it's done another way. Now, real quickly, right now, it looks like, Emily, I think I agree with you. I'm going to do real quick. Yeah, I think that 36 is an outlier, I think. Based on just looking at what I just did, it seems like it actually was literally hand-waving. But we'll come back to that towards the end when I have you guys collect your own data besides the state data. We're going to analyze, fittingly enough, Bend snowfall data today. You've got some fun data to play with. We can't use today's data because it's still being dated. But we've got some historic data over the past 80 or 90 years we'll get into today. But the big idea is that's your box plot and it gives you a nice visual. I love the identification of the middle 50, the lower 50, the upper 50, the upper 25, the lower 25. You can't get any more specific than that, right? Your increments of 25. Sometimes you'll read of things called quintiles. What do you think a quintile is? Break it into 5 regions, not 4. Sometimes you'll see deciles, 10 regions, not 4 or 5. Every once in a blue moon you'll see octals, 8, right? If you can handle quartiles, you can handle anything. The government loves its quintiles, I've noticed. It loves its quintiles. On break, I'm going to pull up one of my favorite graphs, the distribution of wealth across the United States by quintile. So while you guys are wondering, I'll try and grab that in Google and pull it up for you. But if you can handle a quartile, you can handle about anything. Because it's a matter of reshuffling the percentiles. Quintiles are P20, P40, P60, P80, and P100-ish. Now the thing about that is you lose the median, don't you? You jump from 40 to 60. But sometimes people don't care about the median. That's not as important to them as the 5 regions. Deciles do pick up the median, because 50, 10, 20, 30, 40, 50, and so forth. So let's take 5. All these talk of aisles is starting to get you guys a little bit nauseous, I think. Take 5, get some air, get some water, go play in the snow for a couple minutes. I'll grab a little graph and we'll come back and collect some fun data. I hope it's fun data for you.